All right, Physics Johnny here, and what we're going to do today, we're going to do some projectile motion problems as a start in physics. Your step 0 for today, get comfortable. Find your comfortable clothes, get comfortable. Let's get ready to solve a problem. So let's get started. If you want to try to solve this problem after I introduce it, you can pause the video and try to solve it on your own, and then I'll show you how to solve it. So let's say we have a baseball that's hit off of a bat at an angle of 30 degrees to the horizontal at a speed of 25 meters per second, and it's hit from 40 meters away from a building, and the building is 7 meters tall. Obviously not to scale. And the question is, will the ball land on the roof or not? All right, so we know that the ball is going to follow a parabolic trajectory. And the question is, does the ball have enough speed to land on the roof, or are we in danger of breaking one of these windows? So that's the question. All right. So the first thing we have to do is we have to break the 25 meters per second into its components. So I'll draw that up here. Multiplying the 25 meters per second times the sine of theta, sine of 30 degrees, you should get 12.5 meters per second. And then multiplying 25 by the cosine of 30 degrees, you should get approximately 21.7 meters per second. All right, now, okay, so we have to think about the problem a little bit. So the fastest way to answer this problem is really going to be set on how high the projectile is going to be when it travels a horizontal distance of 40 meters. All right, so the 40 meters is really the parameter that's setting the tone for this problem. What we're going to do is we're going to use the horizontal velocity, and it's going to go with the horizontal speed. So the horizontal velocity, as you know from your physics teacher, is constant. So every second this projectile is in the air, it's traveling 21.7 meters down the field. And we want to know how long it takes to go 40 meters. So the time, so T, to cover 40 meters is going to be the distance, 40 meters, divided by the speed, 21.7 meters every second. So the meters will cancel out, and we're going to get a result in seconds. And that result is 1.85 seconds. So just a note, I use the 21.7 as a rounded value, and in my calculator I use the exact value that I got when I did 25 times the cosine of 30. And this itself is a rounded value. So what that means is it's going to reach this plane at a time of 1.85 seconds. The next part is to figure out how high will the projectile be at 1.85 seconds. Well, how high, that's a question about the vertical position of the projectile. So we have to now work with the vertical motion of the projectile. This is Vy0. All right, so if you look through your list of equations that your professor probably gave you, you probably have something to this effect. So that the vertical position is equal to the initial vertical position plus the initial vertical velocity times time plus 1/2 the vertical acceleration times the square of the time. All right, so you probably have an equation that looks something of this nature. And what we're solving for is the vertical position at a time of 1.85 seconds. So plugging in, we have y is equal to, and the initial vertical position is 0, and the initial vertical velocity is 12.5 meters per second. The time is 1.85 seconds. You can use your exact value, plus 1/2 times a negative 9.8 meters per second times 1.85 seconds squared. This, we get that the vertical position is 3686, so I'm going to round that to 6.4 meters. So here's our vertical position, and let's look at what that means. So the roof of the building is 7 meters tall. So when the projectile covers this 40 meters in 1.85 seconds, it's going to be 6.4, and 6.4 meters is less than 7 meters. And so I'm afraid that we are in danger of breaking one of these windows. Oh no! Thank you for watching. Bye.